And welcome to our second kinematics video for level 2 calculus. Remember, kinematics is the study of motion. And remember this diagram we introduced in the last video to help us determine a displacement velocity or acceleration function. Right, one thing we didn't mention in the last video was direction. We need to be familiar. If we're going to the right, it's positive. If we're going up, we call it positive. If we're going to the left, we call it negative. And if we're traveling down, it's negative. Because kinematics is a one-dimensional for now, and we need to know that the direction is positive or negative. Remember, the rocket ship in the last example was always in the positive direction, so we didn't get worried about that. All right, we'll look at one example with three parts to it. So here we go. A ball is dropped from the first observatory deck on the Empire State Building and falls to the ground, which is 320 meters in height. So here's part A. What's the velocity of the ball 3 seconds after it was released? Well, we're going to start with an acceleration function because we're going to assume the only acceleration on the ball is gravity. And gravity has a value of 9.8. Now it's negative because we're going to draw our diagram. Here's our building and the ball is falling down in a negative direction, so it's negative 9.8. Right, well, here's our diagram. We're going to focus on the anti-differentiation to get to velocity. So we need to anti-differentiate it. We need to bring back the x, and we need to plus c. But remember, we're using velocity and time, so we're going to replace the x with a t. So our velocity function is negative 9.8t plus c. Now, we know when we're holding the ball at the top of the observatory, it's got a zero velocity at the start of 0 seconds. So when t is 0, we're going to substitute 0 in for t, and we're going to put it equal to a velocity of 0, so we get negative 9.8 times 0 plus c is 0, which means c must be 0 as well. So we've just established that c is 0, so our velocity function is negative 9.8t. Right, let's use it to work out the velocity 3 seconds after the ball is released. So we're going to substitute in 3 to get velocity is equal to negative 9.8 times 3, which is negative 29.4 meters a second. The negative means it's traveling downwards and it's traveling at a speed of 29.4 meters per second. Right, part B, how long does it take to reach the ground? That's a good question. We know the acceleration function and we know the velocity function. We've now got to do one more anti-differentiation to get the distance or displacement function. So here we go. We need to add 1 on to the power of t to get t to the power of 2. We need to divide by the new power of 2, and we need to plus on our c. But I'm going to put d instead because we don't want to get confused with c. Right, so our displacement function is negative 9.8t squared divided by 2 plus d. Now again, think about the building. We are 320 meters up in a positive direction. So 320 is our d. So our displacement function is negative 9.8t squared over 2 plus 320. Right, so how long does it take to reach the ground? Well, we're going to take the displacement function and put it equal to 0, because 0 represents the ground. So let's solve it. We're going to minus 320 off both sides. We're going to times by 2 on both sides. We're going to divide by negative 9.8 on both sides. And now we're going to take the square root to get a time of 8.08 seconds. It takes just over 8 seconds to reach the ground. Right, our last question. What's the velocity of the ball when it reaches the ground? Well, we've already figured out the acceleration, velocity, and displacement functions using anti-differentiation. So we just need to use the velocity function and work out the velocity after 8.08 seconds, and we get a velocity of negative 79.2 meters per second, which I've rounded to 2 decimal places. The negative means it's going down, and it's got a speed of nearly 80 meters a second. Now, in real life, that probably won't happen because there is such a thing as terminal velocity, but we're not going to worry about that right now. Great. Thank you very much for watching.